If you want to get something into the air quickly, you simply strap a rocket on it. This is called JATO, Jet Assisted Takeoff. We take a brief look at the history of jet assisted takeoff. We also explore the history of how true military transports came to be. Lastly, we look at a number of great seaplanes. Once the seaplane ruled the skies. Later, the runway became the norm. We discover why and how this occurred. Powered-assisted takeoff works much better if the aircraft in question is able to fly in the first place. It's also helpful to make sure the rocket you use is safe and mounted properly. One of the pioneers of rocket and jet-assisted takeoff was the German Luftwaffe during World War II. Rocket-assisted takeoff, or RATO, provides two benefits. Firstly, it saves fuel in getting heavier loads into the air, and secondly, it shortens the takeoff run. The benefits of RATO have long been recognised, and many weird and wonderful experiments have been conducted in these areas. The Germans fitted their early pods to just about every plane in their arsenal at one time or another. The pods were unpredictable and dangerous, but the Germans were successful at using the technique in a number of areas. What was important to the Germans was shorter takeoff runs, as most of the airfields had become cratered after bombing attacks. At this time, during the final phases of the war, advanced planes had become less tolerant of rough runways. Therefore, it was easier to maintain shorter runways by using assisted takeoffs. The fuels used in rocket engines were highly active and fairly unstable. The substances required careful handling. The pods produced a powerful and violent burn to produce substantial power, but the cocktail could easily be set off by accident. The result of a pod exploding on the ground would have been devastating, so many safety procedures were adopted, including the use of protective clothing, which also reduced the chance of static electricity igniting a pod while it was prepared. Flying boats have an inherent problem in that it takes a lot of fuel to unstick them from the water, so assisted takeoff was very beneficial to the flying boat squadrons. One of the problems with jet and rocket assisted takeoffs was they did have a tendency of damaging the runway by burning it up. This was obviously not a factor for the flying boat, which made the assisted takeoff even more favourable for use in this area. The United States of America also experimented with RATO, and various applications were tried, tested and finally refined to the point of being usable. This is a Martin B-26 getting a rocket shaft to reduce its takeoff distance. The interest in rocket-assisted takeoff became more intense with the arrival of the jet age. Jets required much longer and higher quality runways than the propeller-driven counterparts. Another problem with early jets was their jet engines could be damaged by debris on the runway, and their takeoff speed was becoming higher and higher. The main problem was that the runways were vulnerable but necessary for the jet age. RATO was proving to be the most beneficial in saving fuel during the takeoff of the jet aircraft. And although the practice did reduce takeoff distances, the runway issue always remained. JATO and RATO also presented their own problems. They required extra personnel, air-based space, and the storing of highly volatile substances. These problems were even more critical when assisted takeoff was tried on carriers. One of the most extreme trials of assisted takeoff in an attempt to do away with runways for fighter aircraft was to strap them onto trucks. Called a zero-length launch system, the idea is simply to shoot the plane straight off the back of a truck. Numerous aircraft were tested in this manner, and as crazy as the idea appears, it was surprisingly successful. The launch apparatus was developed by Martin Company, now known as Lockheed Martin. The idea was to be able to disperse aircraft over a wide area and reduce the need for runways and large bases. The first launch of this type was conducted in December 1953. The aircraft was an unmanned F-83 and it was shot off into the desert. The first piloted version was launched not long after January 1954. The recorded acceleration loads were surprisingly low, only 3.4 Gs force, which is only slightly higher than a normal aircraft carrier takeoff using a slingshot. Within the few seconds of rocket burn, the plane reached a speed of about 175 miles per hour, which is well above the stall speed of the F-83. The pilot reported there was no problem controlling the aircraft. In all, the idea of zero launch proved workable. However, it didn't really answer the most desired outcome, which would be an aircraft that could take off vertically. The concept was further improved and was used in small numbers, but it was really not practical for a lot of reasons and was abandoned. One aircraft that did address the problems of runway length and fuel efficiency on takeoff is the C-130 Hercules. The C-130 from day one was just a great design, and over nearly 50 years of development only improved it to be one of the most outstanding and versatile planes ever built. It can reach takeoff in very short distances. The Hercules is also able to use very substandard runways. This is a Hercules using JATO. It cuts its standard takeoff distance from 1,500 feet to a mere 800 feet. When the United States Air Force required a plane to move troops and equipment, Lockheed was employed to build the Hercules. At this time, moves were made to try to reduce the takeoff distance to a minimum. Lockheed built a control model C-130 and added 2 jet engines to the existing 4 turboprop engines. The extra jets forced more air out over the control surfaces, which increased lift, forcing the aircraft into the air after only 400 feet. Today, some Hercules are fitted with JATO, and this is a testimony to the fact that JATO and RATO did end up as a very usable concept, but they're only suitable to certain planes and conditions. After World War II, much surplus was available. So the surplus was often used for the purpose that it wasn't designed for. This is a KV-50, which was a modified B-29 bomber and has jet engines fitted to the wingtips to assist in takeoff. But more importantly, the jet increases the bomber's speed to make it able to accomplish in-flight refueling for fighters. Although planes such as the KV-50 were capable of in-flight refueling, they and their like were not capable of transporting tanks or any real military hardware. It was a time of modifying to create a new plane rather than design new and purpose-built machines. This 6-engine B-36 is a classic example as it was developed into the XC-99. Its large cylindrical fuselage was capable of transporting 50 tons of cargo or 400 troops. Previous World War II aircraft struggled with 10 tons of load, so the modified B-36 was still a huge achievement. But the planes were still limited to what could be actually fitted into the fuselage to make up the 50 tons. The XC-99 was at the time the world's largest plane, but it wasn't proceeded with. Only one was ever built. The plane flew safely and economically from 1949 to 1957. The idea of transforming aircraft was not successful in most cases. For transports to work well, They need to be able to get troops to where they are needed and also move with the troops and the enormous amount of equipment they require. This means transporting trucks, jeeps and even tanks. The XC-99, in fairness, would have been an ideal civilian transporter, but it fell very short from a military point of view. In fact, Pan Am had ordered a number of the planes, but the order fell through, so the Convair XC-99 never came to be. There wasn't a transporter as big as the XC-99 for many years, and these planes were in the form of the DC-10 and the Jumbo 747. At the same time the XC-99 was being developed, the US Navy was working with the Lockheed Company to build a true transport and cargo plane called the Constitution. This plane showed more potential as a troop transport and was also suitable as a commercial airliner. In fact, Pan Am engineers served as consultants on the project. The Constitution had a wingspan of over 190 feet and a length of 156 feet and was the biggest plane to be built by Lockheed until construction began on its new C-5 Galaxy. The pressurised fuselage of the plane was double-decked and had accommodation on both decks. Two circular stairways, one forward and one aft, joined the decks. The aircraft could be configured in such a manner that cargo could be carried below and troops on the upper deck, but a vehicle's size was restricted to that of a jeep. The Constitution had seating for about 200 sailors, but it could be altered to seat 110 passengers for civilian use. To show the plane's size, this is a service door that engineers could use to crawl through the wing to gain access to the engines. In the end, neither the Navy or any civilian company placed orders for the Constitution. Only two of these craft were built, and the Navy used the planes from 1946 to 1953. Later they were sold off to a civil operator, but when confronted with the cost of having the pair certified for civil use, the company lost confidence, and the two magnificent planes were scrapped. The 1945 Douglas C-74 Globemaster was another example of modifying a plane to become more useful. The Globemaster was fitted with a new fuselage and became the C-124. This was a major redesign, and the designers addressed many problems of the past, in particular the need to accommodate large vehicles. The swinging front doors were a new adaptation, as the earlier C-74 had a lift built into the floor. For rapid and efficient loading and unloading and maximising the use of cargo space, end loading is essential, as it presents fewer problems than any other method, and it was the technique that was incorporated on the C-124. The Globemaster was the real breakthrough in the materialisation of true and purpose-built military transport aircraft. The first flight by a C-124 took place on the 27th of November 1949, and the first operational aircraft were delivered in May 1950. Production ran through to May 1955. The improved 124C had more powerful engines, wingtip-mounted combustion heaters that provided cabin heating, and wing and tail surface de-icing. It was the Globe that set the goals for future designers to improve upon, but for the Globemaster, time ran out, and they were scrapped and melted down to become ingots for use in the next generation of machine. It may interest many people to know that due to a lack of runways and airports, the first big passenger aircraft were mostly seaplanes. Lakes, rivers, bays and oceans provided ready-made runways. By the time World War II started, these runways were not always located where runways were needed, so a shift to make runways and planes with landing gear became the usual configuration for aircraft. A British company called Shorts became one of the leaders in manufacturing large seaplanes, or flying boats as they are sometimes called. American companies also built many seaplanes at this time. In fact, all the major aviation companies had at one time built seaplanes. This is a Boeing Clipper under construction. As air travel became more popular during the 1930s, one trip of Pan American Airlines asked Boeing for a long-range, four-engine flying boat. Boeing developed the 314, nicknamed the Clipper after great sailing ships of the day. Clippers had large windows, dressing rooms and a dining salon that could be turned into a lounge or bridal suite. The Clipper's 74 seats converted into 40 bunks for overnight travellers, and four-star catered gourmet meals were served from its galley. A factor that kept seaplanes so popular over their land-based counterparts was the fact that engines were not as reliable as they are today. Hence, people felt safer flying over oceans in seaplanes. The German Dornier company also tried to get involved with transatlantic passenger flight business with giant seaplanes. The Luftwaffe had already used seaplanes. However, it was the American Navy that employed the largest collection of different types and extended their use. During the war years, it was the seaplane that was used extensively as U-boat spotters and hunters. The Martin PBM Mariner is an example, and a number of variants were built, and they were mainly used as transports, but some were heavily armed and radar capable. They went on to become very deadly submarine killers. The PBM was so successful that they pushed back construction of the big brother, the enormous four-engine Martin Mars. Only a handful of the Mars made it into production. It had a wingspan of 61 metres and a height of 14.64 metres. The Mars was the largest aircraft in operation from 1942 until the first Boeing 747 flew. The Mars is still the largest operational flying boat. The range of the plane was about 5,000 miles. It weighed 140,000 pounds and has two decks. In its original form, it required a crew of 11 airmen. The plane was a huge success and broke many records. The Mars broke the endurance record by staying aloft for 32 hours and 17 minutes, covering 7,403 kilometres. This is still respectable by today's standards. It was the plane's size that ultimately became its downfall. It was too daunting a task for the US Navy to arm it and upgrade it for military use, and at the time there wasn't a viable commercial use for such a large seaplane. So the Mars' smaller relative, the Mariner, remained the Navy's seaplane of choice. The few that were made were all used for heavy transport. The Mars was so large it inspired the news organisations of the day to cover the prototype's launch. On November 5, 1941, the prototype was launched from the Martin factory in Little River. Unfortunately, during testing, she threw a propeller blade from the No. 3 engine, which started a fire. It took 6 months to repair the damage. Fire has played an interesting role in the Mars history, as some are still used today as water bombers and can wet down 3 to 4 acres per drop. The Mariner remained in service after the Second World War, and even through to the Korean conflict, and the Martin Company continued to build seaplanes for the Navy until about 1960. But the halcyon days of the seaplane ended soon after the war, as many runways were available, and aircraft to use them were also available in their thousands, so the chapter of seaplanes in the history of aviation drew to a close. Another example of a large seaplane is the HK-1. The HK-1 also went under the name of Hercules. Howard Hughes designed the craft, and his small but dedicated team constructed the aircraft. The Hercules' first and only flight occurred on the 2nd of November 1947. Howard Hughes fired up the 8 radial engines for taxi tests and thrilled thousands of onlookers with an unannounced flight. The Hercules lifted 33 feet and flew 1 mile in less than a minute at a top speed of 80 miles per hour before making a perfect landing. After the historic event, the Hercules was returned to its hangar, never to fly again. As ordered by Hughes, it was constantly maintained and kept in flight-ready condition until he died in 1976. Hughes built the plane mostly out of wood, as there was a shortage of steel due to the war. Much controversy surrounded the plane and Hughes at this time. There was one seaplane that continued throughout the war and excelled in areas that other aircraft simply could not operate. Even though the plane was dated before the war started, it overcame its age to go on to be one of the most famous World War II seaplanes in history. The United States and the Dutch also utilised the outstanding services that the Catalina could provide. The distinguishing feature of the Model 5 and its predecessors is the bubble-type blister on the fuselage. This was used as a gun turret and offered superb visibility for spotting and tracking the enemy. The blister was also very useful in another role, that of sea rescues. The visibility from the blister was greatly appreciated by Catalina crews that were engaged in rescuing downed pilots and shipwrecked victims during the war. The Catalina was both a success in battle actions and commercial applications. In fact, after the war, many went on to continue in service for many years. It was not in any way an outstanding performance craft, but it was outstanding in simplicity, ruggedness, reliability, ease of service and long range. We will look more deeply into the Catalina story in future episodes.